What's up, folks? How is it going? This is Avish here, and welcome to DevOps Challenge Hub. So let's start with today's interview question. So today's interview question is: what quality gate conditions have you implemented? Why and how did you decide them? So let's first discuss what quality gate conditions we implemented. We implemented that no new blocker issues should be there. Threshold is zero. No new critical vulnerabilities. No new bugs. Coverage on new code should be greater than equal to 80%. Duplication on new code less than 3%. Security rating should be A, reliability rating A, maintainability rating A, greenfields only. Greenfields means it's only like a completely new project started from scratch, no existing code base, no legacy code. So no inherited technical debt. So why each condition? No new blocker issues. Like blocker issues will cause bad customer experience. It will cause runtime crash and complete functional failure. So obviously, no new blocker issues. No new critical vulnerabilities. Security issues are risk, SQL injection, hard-coded secrets. So, and these are all known risks and already fixes are available, known for this new means all these critical vulnerabilities because these are the known issues. So this should be fixed. No new bugs. Mostly the SonarQube bug detections are kind of logical error or coding defects that can be fixed. That can be easily fixed. So, and we wanted to reduce production incidents, so that's why no new bugs. Whatever whatever code written newly. Coverage on new code greater than 80%. So definitely we wanted 100%. Every team thinks that they will get 100% code coverage, but that is not practical and also not realistic. And sometimes it happens like developers start writing low value test cases to justify that 100% benchmark. So Jan, like 80% is the widely used accepted industry benchmark. And initially we actually started with 90%. But after that, too many pipelines started failing, and developers spending more time into writing unit test cases, and they were like trying to gain the metric than writing useful test cases. So then we dialed it back to 80%. Duplication on new code less than 3%. So copy paste of the code should be avoided. Like that same code is copy pasted in 10 different files. So if tomorrow there is a bug, so you have to go and fix in 10 files, right? And people may forget, right? They may fix in five places. They forgot other places where that same duplicate code is there. So that's why duplicate code should be very less. So that's and this is also kind of industry standard. So that's why we kept less than 3%. And security rating A, reliability rating A, mostly for management readable goal. Instead of explaining individual metrics, we would say that our code pass security rating A and reliability rating A. Maintainability rating A, it's only for greenfield. So we deliberately excluded legacy project because legacy project already had so many code smells and like there are like thousands of 10,000, 20,000, 40, 50,000 lines of code and there are like maybe 400, 500 code smells are there. And it's not possible to fix all of them into one sprint. So we kept them separately. We only made sure that new code should be perfect. Whatever new code we are writing, there should not be any, we should not increase the technical debt and should not introduce bugs, etc. So how we decided the threshold, it's not arbitrarily. What we did, initial 2 weeks, we ran the SonarQube without the quality gate. And we collected all the data, how many vulnerabilities, bugs, technical debt, code coverage, etc. And we found that we are getting 75% code coverage. So 80% is achievable. And duplication of the code, also duplicate code was also less than 3%. So it was realistic, we kept that. And security team gave hard mandate that there should be zero vulnerabilities, zero critical vulnerabilities. And also product team was pushing that faster release cycle. So we avoided threshold that will delay the release and would cause daily pipeline failures. So basically, it's a collaborative effort between development team, product team, and security team, all right, and quality assurance team. So quality assurance team want to maintain quality. Product team has a pressure that they have to deliver it faster. And security team also has mandate that any security risk should not be there. So it was like it was a decision taken not unilaterally. After so much discussion, we have arrived to these numbers, and after every quarter, we as a team, this majority improved. And how it was enforced technically, we applied this quality gate, and even for the pull request also, we added that quality gate. So on pull request, the GitHub action triggered, and quality gate results passed back to the pull request. We enabled the PR declaration so that quality gate results can be seen inside the pull request. So the developer or the senior developer who is reviewing the code, he will be able to check the uh, quality gate results in the pull request. So at the review term itself, if there is some issue, it can be rejected. And sometimes we need to bypass the process. So we, for emergency purpose, like we need to bypass the process, even if the quality gate failed, but we need to release it to production. So for that, we had a documented process that senior engineer will review, give approval only on some emergency situation, and will create a Jira ticket explaining the process. So this prevented the gate from becoming a bottleneck while maintaining accountability. And for legacy code, we applied the clean as you code principle. We only gated on a new code, not the entire code base, because the entire code base already had like thousands of existing issues, and we didn't want to block the release because of those old issues. Whatever new code we are writing, we wanted to make that our quality standard is met and the quality gate criteria is met. So that's it for today. Hope you like this video. Please like, share, and subscribe. And see you again in the next video.